0.50 kg mass oscillates in a simple harmonic motion on a spring with a constant rigidity of 200 Newton per meter. What are the period and the frequency of the oscillation? First, we are going to identify the given the mass of 0.50 kg and the stiffness or rigidity of 200 Newton per meter. And then, identify the problem, which is the period and the frequency. Insert the equation. To get the frequency is equal to 1 over 2 pi and the square root of stiffness or rigidity over the mass. And to get the period is equal to 2 pi and the square root of mass over the stiffness or the rigidity. Or we could find the period through 1 over the frequency. I have here my solution. Distribute all the given. So 1 over 2 and equivalent of pi is 3.14. Square root of the stiffness or rigidity is equal to 200 Newton per meter and the mass of 0.50 kg. Since Newton is a derived unit, I change Newton to kilogram per meter per second squared in order for me to determine easily which unit can be cancelled out. So cancel the kilogram and then the meter. We only have the second squared remain. 2 multiplied by 3.14 is equal to 6.28 and 200 divided by 0.50 is equal to 400. 1 divided by 6.28 is equal to 0.15924 and 0.15924 square root of 400 over s squared is equal to 3.1848 Hertz. And we have found now the frequency of the oscillation of a 0.50 kg mass oscillates in a simple harmonic motion. And now, since we have already our frequency, we can easily get the period through 1 divided by the frequency. Substitute the frequency, 3.1848 Hertz. 1 divided by 3.1848 Hertz is equal to 0.31 seconds. And this is now the period of a 0.50 kg mass oscillates in a simple harmonic motion. In 0.50 kg mass oscillates in a simple harmonic motion on a spring with a constant rigidity of 200 Newton per meter, we have the period of 0.31 seconds and a frequency of 3.19 Hz. That means the stiffness or rigidity of an object as well as its mass is the factor that affects the oscillation. What mass on spring with a stiffness constant of 10 Newton per meter is needed to oscillating a period of 2.0 seconds? Let's now identify again the given. Stiffness or rigidity of 10 Newton per meter and a time of 2.0 seconds. And the problem is to find the mass. I'm going to use the equation of period to derive for the equation in getting the mass. So time over 2 pi is equal to square root of mass over the rigidity or the stiffness, squared of the both sides in order to remove the square root. After removing the square root, we are going to square the time, and 2 multiplied by 2 is equal to 4, and also square the pi. Multiplied again both sides by rigidity or the stiffness, represents letter K, in order to remain the mass. Cancel K and K, and now we have derived the formula of mass. We are now going to use our derived formula for getting the mass. Mass is equal to rigidity or the stiffness multiplied by time squared over 4 pi squared. And then substitute all the given value. Stiffness or rigidity is equivalent to 10 Newton per meter, and then the given time or the period 2.0 seconds. and the value of pi 3.14. 2.0 seconds raised to the power of 2 is equal to 4 seconds squared, and 3.14 raised to the power of 2 is equal to 9.8596. Since Newton is a derived quantity, I use the expression in terms of SI base units, which is the kilogram meter per second squared. 10 multiplied by 4 is equal to 40, and 4 multiplied by 9.8596 is equal to 39.438. Cancel the meter and the second squared. 40 divided by 39.438 is equal to 1.014 kilogram. This is now the mass on a spring with a stiffness constant of 10 Newton per meter to oscillate in a period of 2.0 seconds. 1.014 kilogram mass is needed on a spring with a stiffness constant of 10 Newton per meter is needed to oscillate in a period of 2.0 seconds. This problem implies that mass on a spring varies the period in oscillating. The simple pendulum in your grandfather's clock is 1.0 meter long. Calculate for the period and the frequency. Given the length of 1.0 meter and the gravitational force of 9.8 meter per second squared, and then identify the problem, which is the period and the frequency, and use the equation of 2 pi in the square root of length over the acceleration due to the gravity. Substitute the value of pi, which is 3.14, and the length of 1.0 meter, and the acceleration due to the gravity, 9.8 meter per second squared. Cancel meter and meter. 2 multiplied by 3.14 is equal to 6.28, and 1 divided by 9.8 is equal to 0.10204, and copy the a's squared. 6.28 and the square root of 0.10204 s squared is equal to 2s or 2 seconds. We have now the period of the simple pendulum. Let us now proceed to the second problem, which is finding the frequency. In order to get frequency, we have 1 divided by the period. Substitute the period of simple pendulum, we have 2 seconds. 1 divided by 2 seconds is equal to 0.5 seconds raised to the power of -1, or 0.5 Hertz. We have now the frequency of the simple pendulum. In simple pendulum of my grandfather's clock with a 1 meter long has a period of 2 seconds and a frequency of 0.5 Hertz. This problem implies that the length of the clock affects the period and the frequency of the oscillation. Simple harmonic motion is all about the restoring force of repetitive movement back and forth through an equilibrium position. Thus, the maximum displacement on one side is equal to the maximum displacement on the other side.